Subscribe our Nehra Classes YouTube channel to watch free live training sessions and to avail the membership facilities and additional perks, click the join button. Hello everyone, I Vikas Nehra welcome you all to session number 101 of our ongoing RHCSA version 10 training. And in this session, we will talk about DNS server configuration in RHEL 10. But before I show you how can we configure the DNS server in RHEL 10 machine, we must know what is DNS and why do we use it. DNS stands for Domain Name Server or Domain Name System. Every device on internet is connected to a massive global hierarchy of DNS servers. Organizations usually operate multiple DNS servers, and even home routers ship with small DNS forwarders. As the name suggests, Domain Name System is a TCP/IP network service that converts human-friendly names into IP addresses. Although DNS performs many more functions, its primary role is name to IP and IP to name translation. As human, we it's easy for us to remember the names instead of numbers. But on internet, we use IP addresses. So we need a mechanism which can actually translate the name into the IP address and the vice versa. So DNS is used for that purpose. So what is the main role of DNS? It translates name to IP and IP to name. Whenever I type www.google.com in my web browser, so what happens here? As soon as I press the enter key on the keyboard, I can access the Google homepage. But at the back end, what is happening? Whenever I type google.com, browser looks for this address in my etc hosts file. If it is not available there, it goes to DNS and DNS checks what is the corresponding IP address. And after resolving it, it allows us to access that page or service on internet. So if you want to know the IP address of any web page that is present on internet, you can check it with the help of nslookup command. This command shows you the corresponding IP address of any website or any web page or any URL available on internet. If you want to know the IP address of Google DNS, that is 8.8.8.8 and 8.8.4.4. So how our machine is resolving it? It's because of the DNS server. Let me explain you the working of DNS server. When user types any website name like example.com, computer DNS resolver sends a request to the DNS server, which then looks for the IP address and then resolves it. And after that, your computer sends the request to that particular page or the website or the URL. So computer connects to the website with the help of IP address, which is resolved with the help of the DNS, that is domain name system or domain name server. How DNS works internally? Internally, there are two modes. Name to IP resolution, which is known as forward lookup query, and IP to name resolution, which is known as reverse lookup query. A forward lookup is when a client queries a DNS server to obtain the IPv4 or IPv6 address for a hostname. And a reverse lookup translates an IP address back into a hostname using PTR records. Reverse lookup use the in-adder.arpa domain for IPv4. Okay, I will explain all those things in the few minutes. DNS configuration on client machines is done with the help of this /etc/resolve.conf file. This file is actually responsible for deciding which name server to use. So by default, our machine is using the Google DNS and our own DNS provided by VMware. Okay. Now I will talk about DNS namespace and hierarchy. This is the DNS namespace and hierarchy. At the top, we have the root server in the DNS hierarchy. It is represented by a dot. Generally, it is not mentioned in the URL. Root name server knows where to find the authoritative servers for all top level domains. What are the top level domains? These are the top level domains. .com, .org, .net, .edu, .in. What are the top level domains? Domains directly under the root server. These are the top level domains like .com, .org, .net, etc. These are generic top level domains. We call them GTLDs. Each TLD server knows where to find the authoritative server for the domain registered under it. Under these top level domains, we further have second level domains like we have here example, example.com, ubuntu.com, nehraclasses.in, nehraclasses.com. So under the top level domains, we have second level domains. Then under second level domains, we have subdomains like www.nehraclasses.com, ftp.linux.org. So these are the subdomains. This www is a subdomain of example.com. It typically points to the web server of the site. What is fully qualified domain name? This is the example of fully qualified domain name, where at the end we have the dot which represents root, which is often omitted. There are total logical 13 root servers starting from A to M. Each is actually distributed using Anycast and consists of many physical servers worldwide. Now we will talk about DNS zones. A zone is a portion of DNS managed by a specific DNS server. Zone contains resource records. So these are the types of records that we can have in a zone in DNS. If capital A is mentioned there, that means hostname and the IPv4 address. If AAAA is mentioned there, that is for IPv6 address. If PTR is mentioned there, that is for the IP address to hostname. NS is mentioned there, that identifies the authoritative DNS server. What is authoritative DNS server? Which contains its own record for IP addresses and host names with the help of forward lookup files and reverse lookup files. MX is the mail exchanger or the mail server for a domain. SOA is the start of authority record with metadata information. CNAME is the canonical name or the alias for another host name that if you are using with any machine. And glue record is a record for an NS entry or the name server entry. There are different type of DNS servers used. We have a caching only DNS server, and a caching only DNS server can be there with without forwarder or with forwarder. In without forwarder, the DNS server consults the root server first, then the top level domain servers, and then the authoritative servers. With forwarder, client sends the query to the local DNS, which then forwards the query to the internet DNS. So this is the caching only DNS server with forwarder. Now we will talk about the authoritative DNS server. A server that owns a zone, primary or secondary, and holds its zone files is authoritative. And there we have primary or secondary. What is the authoritative server? An authoritative server is the server which holds its zone files for the records. So we are going to configure an authoritative DNS server here. We will mention the IP addresses there and the host names, and then we will try to resolve them with the help of DNS. Okay, now I'm going to show you the configuration of DNS server on RHEL10. So this is the machine which is having the IP address as 192.168.229.137. This machine I'm going to use as the DNS server. So let's start the configuration. First of all, we will set the static hostname in this machine. Let me set the static hostname as dns-primary.naraclasses.local. We will verify the same by running the hostname ctl command. So we have successfully set the static hostname in our machine. After that, we will install the DNS packages, and the packages names are bind and bind-utils. So we will install both these packages in our machine. In my machine, I have already installed these packages. So if your repository is working, you can install these packages with the help of the DNS install command. After installing these packages in your machine, you need to start and enable the named service. Named is the daemon service responsible for the DNS. Systemctl enable ---- now named command we can execute for the same. And after that, we will verify the status of the service, which should be enabled, active, and running. After that, we will do the configuration with the help of the name.conf file. You need to keep in your mind that DNS uses port 53 UDP for queries and port 53 TCP for zone transfer. Okay. So now we need to configure the /etc/named.conf file. Before making changes there in the file, it's better to take the backup of the file first. After taking the backup with the help of cp command, we can edit this file using vi editor. Here you will see double slashes like this. So this is nothing but the commented line. Instead of hash, you can write double slashes. So because we are going to configure the authoritative DNS server here, so we need to make certain changes in this file. So we will allow the DNS server to listen on all interfaces. So to allow the DNS server to listen on all interfaces, we can comment this line: listen on port 53 and listen on V6 port 53. After that, we will go on this line, allow query. Here we will mention the IP address, not the IP address, we will mention the subnet details because we are configuring it for the entire network. We'll mention 192.168.229.0/24 and make sure that you put one space before and one space after. After that, we need to mention the information regarding forward and reverse lookup zones. First, I will mention the details for the forward zone. So we will go at the end of this file, and here we will mention the forward zone details. Zone name narrowclasses.local, type master. This is the name of the file. Uday Kumar, please mute. Allow update, none. Allow query, none. After that, we will mention the details for the reverse lookup zone. Okay, so we have to create these two files. This is the reverse lookup zone file and this is the forward lookup zone file. For reverse lookup zone, we mention the IP address in reverse order. So for the entire network, we will mention it 229.168.129.in.adder.arpa. After creating these files, we will create the forward lookup zone file and then reverse lookup zone file. So we will create this file like this. TTL is the time to live. How long DNS records are allowed to stay cached. Then this section. SOA is the start of authority record. This is the most important record in DNS zone. It defines the primary DNS server and the administrative details like represent the current zone name. SOA means start of authority. This is the name, that is the DNS-primary.narrowclasses.local. Email address of the zone administrator. This parameter is the version number of the zone file. This is the refresh interval. So these are basically seconds representing 1 hour here. How often a slave server checks the master for the updates. 1800, it is time in seconds, that is 30 minutes. How long a slave wait before retrying if the master doesn't respond. 604800, it is again in seconds, that represents 7 days. This parameter defines if slave cannot reach the master for 7 days, it discards its zone data as invalid. And this minimum flag here, it is again time in seconds representing 24 hours here. How long non-existent DNS answers may be cached. Then we have the name server. This is the name server of our DNS server. or the host name of our DNS server. Then the host name of this machine and the IP address. We need to mention the correct IP address here. That is 192.168.229.137. Then mail server information. Then the web server and mail server IP addresses. FTP server alias name is the www.naraclasses.local. After creating this file, we can save it. In the similar fashion, we will create the reverse zone file. And the name of the file is naraclasses.local.rev. You can use any name for the file. In this file also, we will define the record in reverse order like this. Let me mention the correct IP addresses here. The IP address of our machine is 137.229.137. I've already explained these parameters. Here, this is for the reverse lookup query. So this is the IP address, the last digit of the IP address of our DNS server. These are the last digits of our web server, mail server, and in the similar fashion, if we have multiple number of machines, we can mention their IP addresses and host names here. After creating these files, we will make sure that these files are owned by the named user. We will change the permission on both the files. And we will verify the same with the help of ls-lh command. These are the files which are now owned by the named user. After that, we will check whether the configuration file and the forward and reverse lookup zone files are correct or not, whether there are some syntax errors or not. To check the syntax for the name.conf file, we can execute named-check-conf command. If there are errors in the configuration file, this will show you that on this line there is an error present. Let me show you. Let me intentionally create an error here. Suppose if I remove the space, or if I remove this semicolon and save the file and again execute the command, it will show me the error line. There is an error present on line number 19. So this is just to check the configuration, whether the syntax is correct or not. This time there are no errors. In the similar fashion, we will check the syntax in forward lookup zone and reverse lookup zone files also. Named-check-conf, and we will mention the path of the forward lookup zone file. And in the similar fashion, we will check the reverse lookup zone file as well. It is showing okay in case of both. That means we are good to proceed further. Now we need to restart named service, since we made the changes there in the configuration. So it's mandatory to restart the service. After that, we have to add the DNS service in the firewall so that our server can accept the queries. Firewall -cmd -add -service is equal to DNS -permanent, and then we can reload the firewall configuration to apply this rule. After that, we will verify the details of the firewall configuration by running firewall-cmd -list-all command. So DNS service is now added there. Now, after that, we are done with the configuration of the DNS server. Now, we will go on the client machine and we will mention the details for the name server. We can do the same from the same machine as well. In case if you want to use the different machine, you can do it with the help of the different machine. You have to make sure that you mention DNS details there. You need to mention the IP address of your DNS server in the network settings. So either you can use nmcli command, or you can do it with the help of nmtui as well. You can go on a data connection, and here instead of automatic you can use manual, and then you can mention DNS details here. And after that, you need to restart the network manager service. After that, you need to open /etc/resolve.conf file in VI editor, and there you need to comment the existing name servers and mention the details of your own DNS server. Let me mention the IP address of my DNS server, that is 192.168.229.137, and then we can save this file. So the same machine I'm using as the DNS client and the DNS server as well. Okay, now we will test our DNS server. So suppose I want to check the IP address of mail.nehraclasses.local. How can I do that? I'll do it with the help of nslookup command. nslookup mail.nehraclasses.local. It should show me the IP address of this machine. Look at this. This is the IP address which was assigned to this mail.nehraclasses.local. And from where it is getting this information? From the forward lookup zone file. This information is there in the forward lookup zone file. So authoritative DNS server has the record in the zone files from where it is resolving it. In case of caching servers, caching server gets the information from other DNS server. Since we configured the authoritative DNS server, so we already have this information. After that, suppose I want to check the IP address of ftp.nehraclasses.local. So I can execute the nslookup commands for the same, and it will give me the IP address of that machine. In the similar fashion, let me check the IP address of my own DNS server. nslookup dns-primary.nehraclasses.local. So this is the IP address of our DNS server. In the similar fashion, suppose we want to check the host name with the help of IP address. How can we do that? We can do it with the help of dig command. dig-x, and we can mention the IP address, that is 192.168.229.137. I know that this is the IP address of our DNS server, so it will give us the name dns-primary.nehraclasses.local. In the similar fashion, let's check it for this one, www.nehraclasses.local. In the similar fashion, let's check it for 192.168.229.60. It is mail.nehraclasses.local. So from where it is getting this information? It is showing this information with the help of the reverse lookup zone files. Okay, so this is how we can configure the DNS server. Suppose now you want to resolve the IP address and you want to ping a machine. You can directly mention the host name there after the ping command. It will give you the response. And this information is not present in the etc host file. this information is not there. So it is able to ping the machine with the help of the host name because the information is there with the DNS server. So that's it from my side for this session.